Oh, welcome and thank you for joining. Let's take a look at an example of a polynomial division, and this is sort of a special example in a way because as you can see, notice the presence of not just one but two variables in both dividend and divisor. So let's get to work. When this happens, what we're going to do is choose the variable that we want to consider as an independent variable. It can be either x or y. And because we're more used to x, I'm going to pick x as the independent variable, which means that y, so the variable y, will be treated as a coefficient of x. So we'll start off by listing the terms from highest to lowest degree. And I notice that I have an x to the power of 4, an x to the power of 3, and an x to the power of 1 term. So we'll start off by listing the highest degree term, x to the 4. Next will be x to the power of 3 term, which is this one here. And to make things look more like the polynomials we've done in the past, we're going to write y in the spot of the coefficient of x. So, and we have y x to the power of 3. So I don't see x to the power of 2 in the expression, so what I'm going to do is I'm going to make an x squared term and give it a coefficient of 0, which means that we're adding a 0 to this polynomial. Next will be the x term. Again, we have x term to the power of 1 here. Coefficient will be y to the power 3, and it's a negative, so y3x. And the last term would be y to the power of 4. As you can see, we can treat this as the x to the power of 0 term or as a constant. Now we're going to write the divisor. So the divisor is x squared minus y squared. So I will start off by writing the first term, x squared. We do not see an x term, so we will write 0x. And obviously we're going to add the last term in here, which is the negative y squared. So bracket here, we're going to draw the line, and that's where we write the quotient. So we're going to get to work. The process will be the exact same we have followed in polynomial division, where we had only x as independent. So we are comparing the first term in the divisor with the first term in the dividend. We have to check and see how many times x squared goes into x to the 4. So we know how we do that. We're going to go x to the power of 4 divided by x to the power of 2. So that would be x squared, which means that x squared goes into x4 x squared times. So x squared will be the first term in the coefficient, in the quotient. So next we're multiplying x squared by every term in the divisor, which means x squared times x squared will give x to the 4. And then x squared times 0x is 0x to the power of 3. And x squared times negative y squared is negative y squared x squared. Draw the line and subtract. x4 minus x to the power 4 is 0. Yx to the power 3 minus 0x to the power of 3 is yx to the power of 3. 0x squared minus negative y squared x squared is positive y squared x squared. We're bringing down the next term, which is negative y3x. So next we do the same thing again. We are comparing the first term in the divisor to the first term in the polynomial, whatever is left out of it. So as you can see here, we have yx to the power of 3, and we'll say that x squared goes into yx to the power of 3 yx times. Okay, so we just divide yx3 by x squared. That's how we find how many times x squared will go into the first term of the polynomial. So we have plus yx. Again, same story. we multiply yx by every term in the divisor, and we list all the terms down here. So yx times x squared is yx to the power of 3. Yx times 0x is 0x to the power of 2. Yx times negative y squared is negative y cubed x. Draw the line again. Subtract. Yx cubed minus yx cubed, 0. Y squared x squared minus 0x squared is y squared x squared. Negative y3x minus negative y3x is 0x. You can write plus 0x minus 0x, doesn't matter. We are bringing down negative y to the power of 4. So next again, we are comparing x squared to y squared x squared. So we want to know how many times x squared goes into y squared x squared, which will be found by dividing y squared x squared by x squared. So as you can see, the answer is y squared, which means that x squared will go into y squared times. So we're writing y squared here. Again, same drill, multiply y squared by every term in the divisor. So y squared times x squared equals x squared y squared, or y squared x squared, same thing. Y squared times 0x is 0xy squared, so 0. And y squared times negative y squared is negative y to the power of 4. Let's subtract. As you can see, we have y squared x squared minus y squared x squared equals 0. Now 0 anything plus 0 anything is also 0. Negative y4 minus negative y4 is 0. So as you can see, the remainder in this case equals 0. So therefore, we're going to say that the quotient qx is x squared plus yz plus y squared. Now to take this a little bit further, as you can see, remainder is 0, which tells us that this divisor, or x squared minus y squared, is a factor. And what's the other factor you're going to say? The other factor must be the quotient. Okay, that's a quotient we obtained by dividing by x squared minus y squared with no remainder, which means that, as a matter of fact, this will be together, these two will be factors of the polynomial given. I hope this made sense, and I encourage you to try the next example in the homework, which is very similar to this. Thank you for learning with me. Bye for now.